Welcome back to Freedom Hillbilly. Today we're going to show you how to use Program 24 to blaze a property line so that your fence is straight and on your property. Wait, didn't we do this already? Yes we did, but we had a clear, unobstructed line of sight between our 2 points, from the point of beginning at point A to point B at the end of a stone wall. If you recall, the second leg of our traverse was a 51 rod trek along the back stone wall to a found monument at point C, and then continuing along through the woods to our terminus at point D. The problem, of course, are all the trees that get in the way of a clear line of sight. This means that we would have to set up a handful of reference stations along that leg of the traverse. So to solve this problem of not having to set up a handful of reference stations close to the line we're blazing, we could set up directly over a point on the line that we're blazing. Now, if it's a property line, it's likely to be clear or mostly clear of any and all obstructions. So we've set up our total station directly at the monument that we found over point C, and we're going to backsite to the prism we set over the monument we found at point B. And we're going to set the telescope on a bearing that goes from point B through point C down to 51 rods to the terminus at point D. So let's go ahead and set up the total robotic station to do just that. I nearly fell over. Anyway, let's move on to our setup. We have two choices here. We could use P24 Refline, or we could use what I like to call the 0-degree bearing setup, because we're going to be setting out on a bearing of 0 degrees. The first step is to backsite to our origin, which is point B. And we don't need anything special. We're just using the angle measurement and distance measurement capabilities of the total station at this point. So we're just in standard mode, P0, and we go ahead and aim this. So there we go. Now we aim and measure, and we hit enter to cycle through the various display options. And what we're looking for is the horizontal distance here, 265.055 feet, which is about 16 rods, which is about a rod short of what was on our survey sketch. Let's make a note of that anyway. So 265.055 feet. So the next step is to define a bearing, and we do this by pressing function 21. What function 21 does is access the internal memory location for the horizontal angle reference. The angle that's in there currently is just random, and it's left over from the previous session. So we want to enter 180 degrees because we're looking southerly back to the origin. So 180, enter. A quick aside, if you want to enter degrees, minutes, seconds, just enter the number, let's say 43.21.56, and that'll enter degrees, minutes, seconds. We want 180 degrees exactly. So 180.0. Now the next step is to swing the total station around 180 degrees, because remember, we want an actual northerly bearing, so we need to swing the station around 180 degrees. And we do this by executing a long press on the left-right arrow button here, which is below the alpha character B. So let's go ahead and do that. Let's see if the camera can pick me up on this side. Wow, what a difference a day makes. We went from spring teaser weekend weather to 15-degree face freezing frigid February weather. So you know that I love you guys. Why don't you return the favor and buy me a coffee? Help me warm up. So let's dive right into this. Wrap this up as quick as we can before the batteries drain and my face freezes. Whew. So we got our telescope pointing down our 0-degree bearing, and we're ready to put it in total robotic mode. So we could take our prism rod and head down that bearing, put our little flags in the ground, well, we're not going to do that bit because we got 2 feet of snowpack that's now currently frozen. But we'll show you how to do it. Shift RPU, 3 remote. Okay, define window, no. Measure reference object, no, we just did it. Please wait, okay, press any key, no, press the enter key only. Now we're ready to set up on our prism rod. Firmly but carefully, 2 hands, press down, roll forward, keep it both hands at all times because you don't want to lose this sucker. It's rugged, but don't test its limits. Let's get down there. All we need to do is set the prism rod into track mode so that the head unit can follow the tracking beacon here. And then all we need to do is stay on the 0 degree bearing. So track mode, TRK, it's gonna search for us. Hopefully it finds us. We've locked onto the prism. So we set it over a flag we've previously set. And we're gonna plumb it. Plumb the little bubble. There, that should be it right there. Boom! There, almost, there. Okay, so we're about a minute off. Let's continue down until we encounter an obstacle or see how far we can go down. We're about 250 feet from the total station, which is about 265 feet from the point of origin. So that's a total of, my brain's freezing. And we're able to get it, let me plumb it up here. I get the plumb, you could do it. Boom, we should be plumb right there. 1 minute and 44 seconds off. So that's pretty good. Let's see how far we can get. Continue on. Now whoa, I nearly just slid on my butt. Whoa. I think this tree is gonna end up in the line of sight. I can see the total station from here if I lean my head. Line of sight, 2 minutes, let's plumb this guy. So we'll call it good at 1 minute. I don't know if you can see that. Shade it. And plumb it in the shade. Boom, 1 minute, 5 seconds or so. Let's call it 1 minute. 393 feet out. And the base is right. Obviously you can see this is in line with the tree, so this thing will block it. Let's try it. Whoa, I think we might pass the tree. Look at that. Look at that, that's perfect. We just barely passed the tree. Let me plumb it. So there we are, we're plumb at 42 seconds, 395 feet. Wow, so let's continue down and see how far we can get. All right, oops. Well, if it got by this tree, it might not get by this next one, which is right here. So here, plumb it. 19 seconds, super duper. Let's continue on. See how far we can get. Oh, there's another tree here. I could see straight. I actually could see straight line of sight right to the total station there. 359. It says the battery's dying on the total station too. The battery's on red here. And it's locked onto the beacon, but we can't see it. So right here. I think we're gonna, there we go. Now we're locked on. 359 degrees, 47 minutes. So we're off by 10 minutes or so. Battery low. Press any key. Okay. I think we're off there. Well, nothing really likes to work, at least not for very long in this frigid February weather. But we're almost all the way there. The last reading we had was at about 660 feet down the line. Anyway, we're gonna wrap it up for today, but we're gonna come back and show you how to use P24 Refline to go around the tree to get even further down closer to our terminus. But that'll be for another day. Well, for me anyway. For you, It's going to be a nice, sexy transition. Less than a second. So we're here at about the last usable location. Every slight movement to the left or right, you avoid one tree, but you end up in another. So we've threaded the needle about as far as we can go. So let's go ahead and calculate our deviation. Currently, we have a horizontal angle of 359 degrees, 49 minutes, and 33 seconds at a horizontal distance of 442.68 feet. So we can get our calculator out. 442.68 feet times the sine of 359 degrees, 49 minutes, and 33 seconds. And that gives us 1.35 feet times 12. That's 16.1 inch. So we have to move our prism rod 16.1 inches that way. So when we're this far out, we're going to have to periodically calculate our deviation error. Now for a fixed angular deviation, our distance error is going to grow and grow and grow the further out we get. Conversely, for a fixed deviation distance, our angular deviation gets smaller and smaller and smaller. And we're going to have to calculate that to come within whatever acceptable error bounds we've set for ourselves. This is why I prefer to use Program 24 Refline, because it does that calculation on the fly in real time, so you can focus on getting your point in the ground rather than on the mechanics of calculating it. So why don't we go ahead and set that up and see how much further we can get using P24. So strictly speaking, there's no reference frame involved here. We just have 2 points on a line, and our total station is set up directly over one of those points. However, we still need to create the area file with those 2 points so that the total station can calculate that line. We also have to establish the station like we did before, but it's a known station, so that's a little easier. And then we can get down to actually blazing the line. So let's start. So first step, program 43. Enter coordinates. Internal memory, number 1. Area file is alpha TRS. Height measure, no. Point number, for consistency, we'll keep our naming convention. So the corner of the stone wall is point B. We'll call it reference station C. So point B, point code is a bound B and D. Northing 0, easting 0, and store yes. So remember, we've relocated our origin to point B this time, just so that we can have the north bearing or north axis. Point number, let's call this one alpha reference station dash, whoops, shift dash C. And this is not a bound, it's a, well, it's a station, STN. We're assuming it's a bound, but spoiler alert, I don't think it is one. We'll get into that in a later video. So northing, well, that was just the distance that we had measured when we did our 0 degree bearing exercise, which was written down in our field book for handy reference, 265.055. 265.055. And easting, of course, is 0. And we're going to store that. And we're done. Those are the 2 points. It pops us back to P0. And we cycle through our environmental parameters and our horizontal angle reference, which we had already established for a 0 degree bearing. But in order to set up the next step, which is the established station, we're going to have to back sight to it anyway. So let's go ahead, just start with that. Program 20, station established. This is a known station, so number 1. Job number TRS, except these. And the occupied station is not RS2, it's RS-C. Recall that? We just did it, so hopefully you remember that. So dash shift C, enter area file alpha TRS, number 1 internal memory, station OK. Yeah, it is. Great, we're on the right track. Back sight to point B, yes, accept that. Target, we've set the target height at 5.0 feet. And here's the reference, yes. Aim at reference object, okay. So it should be on target. Let's hit the aim. Let's registrate that to establish the station. So it's doing its resection calculation and pops out back to P0, and we should be all set. So at this point, we could swing the telescope around just so that we could set up our remote prism rod and get down to blazing. So long press on the left-right arrow key. All right, so at this point, let's just put it into remote mode, set up our prism rod. Well, that was a short walk into the next day. We've already showed you how to set up program 24 in another video, so we'll just run through it really quick. Program 24. Enter. Refline. Same job, TRS, enter. Same parameters, enter. This is a known line, 1. Occupied station is RSC. And area file, TRS, as usual. Straight line, number 1. Line point A is at our origin at point B. Enter. Which is the origin at north 0, east 0. Enter. Ref line point B is the point number reference station C, or point C. Enter. And it's 265.055 north. Distance AB is 265.05. Yes, it is. That's exactly what we had measured, and it stays the same because, well, we haven't moved. Well, we're going to start at 0 because that's the origin at the end of the stone wall, and we're going 51 rods, so that stays the same there. We're setting out, so number 2. And we're going to choose number 1, radial offset and right angle offset. Now the increment is 10 feet. We're going to override that in the field. We could just accept that value though. Now it's asking for a point number. These are the points that are going to be entered into the area, the job file, not the area file, the job file, because it's the result of our measurements. So we're going to start at 20,000 because it's day 2. Every day is 10,000 new points. P code is going to be alpha, B, L, Z for blaze. So radial offset. So this is the first point we want to set out. Since the total station is already 265 feet from the origin, and we're about 31 feet from the total station, that's a total of 296 feet to this point. So we'll start at this point. So let's enter 296. Enter. And the right angle offset is 0 because we want to stay on the line exactly. Put it over the flag. So let's position. There we are. We're plumb right there at 0.08, 0.08. So let's go ahead and registrate that point. Oh, I lost it already. Plumb, boom, there it is. Continue, yes. Point number 20,002, P code blaze, radial offset 306. No, we're going to go down to where we left off yesterday, which was at, I think it was 400 and something or other feet from the total station. So we'll add another 265 to that. Let's just go get set up there. We'll meet you down there. So we're back at the end of the line when we use the 0-degree bearing approach. And that brings us to 708 feet from the origin to this point. So program 24 is telling us we have to go away by 0.2 feet and over by 2.2 feet that way. What we're going to do at this point is take our ruler out, which is graduated in tenths. So let's put it horizontally and put a flag at 2.2. Well, we don't have any flags, so we're going to just go along the line and see how much further we can get. So here's our point. It's the closest we could get to line of sight to be picked up by the total station, which is minus 2.60 feet from the line. So all we have to do is take our ruler rod, measured in tenths, set it horizontally, and put the flag at 2.6. Let's see if I can do this. So here we are. There's our ruler, and we have the flag. Yeah, pretty close to the 2.6 foot mark. Let's see if we can pull in that total station from here. Now, our last point that we were able to pull in with the 0 degree bearing technique was at the tree with the red blaze right there. And let me see if we can, we're fully zoomed in at this point. I'm going to pause it here because I can see it. It's to the left, I mean, it's to the right of the tree with the red blaze, but there's a really skinny, scraggly tree that's kind of obscuring it. Anyway, I'm hoping that brought it in. So we're going to go ahead and registrate that point. Wow, it seems like we're having communications problems. At this distance out, our radio signal is getting weak and it's interfering with our mic wireless, same frequency band, so, you know, there's that. So you can see our setup over here. That's about the furthest point we can get down the line. At this point, it starts going down an embankment to the road right there. So we're going to lose sight anyway because we're going to get out of the angular range. And over here we have our stone wall at the end of the traverse. And this is our blaze tree with our remnant wire fence through it, which is on the other side of the stone wall. Well, over here was the terminus of our traverse. So let's review real quick. The furthest we were able to get with our prism rod was at about 484.94 feet from our total station. Add 265 feet to that, and we get 750 feet back to the origin, which is at the corner of the stone wall. If you recall from our traverse, the legal description indicated that we go 51 rods, which is 841.5 feet to the terminus. So we have about 90 feet plus or minus. And unfortunately, the road is only about 50 feet from here. And typically, you know, the roadways have a right of way. So there's a discrepancy right there in terms of the entire length of our traverse. So we have a more significant problem, and that is we have 16 feet between where we thought the line went and where the evidence in the field indicates that the line is. So here we are standing on this stone wall at the end of our traverse, and it appears that our assumption of the found monument at point C was incorrect. And the reason I say that is because the line we blazed when we went through that point ended up 16 feet away from this stone wall. And typically, stone walls marked the boundary between two properties. And in fact, by convention, the property line was drawn through the center of the stone wall. However, we found a pin on the far side of the stone wall at point B, back at the beginning of this leg of the traverse. And what we found at this end of the traverse was the sugar maple with the remnant wire fence through it. And that is also on the far side of the stone wall. Anyway, little teaser for you. I got a hold of the 1954 survey plan and have some answers. So if you don't want to miss that exciting video where we resolve these issues, make sure you hit the subscribe and the notify, because you don't want to be left out of this one. Nope, no, you don't. Anyway, I'm going to go and grab a hot tea, so we'll call it a wrap, and see you on the next one. Hillbilly out.